Hello students, in our today's video, we will learn about triangles. We would begin by understanding some of the basic notations related to triangles, and then we will move on to understand some of the basic properties of triangle. We will further our discussion and we will introduce and mark the word introduce. We would only introduce similar and congruent triangles. So, and this is targeted for students who are in grade 9. It's targeted for them. So this would be the agenda of my today's video. Okay, so let's get started. So when we talk about triangles, right? So obviously, right from our childhood, we have been hearing about triangles. We, have learned about it, read about it, many times probably in past. So let us just pause for a moment and quickly see or quickly recap what a triangle mean. A very basic question, but remember, students, whenever the question looks very basic, there are actually good and basic informations, hidden in that. So when we talk about a triangle, the first thing that comes into our mind is three straight lines, right? So three straight lines connected to each other makes a triangle. And as the name indicates, we have three angles. So tri means three, angles is, each of these angles, okay? So when we have a bound geometrical figure which has got three angles, so first and foremost thing that we have read from our childhood is in a given plane, the minimum number of straight lines that you need to form a closed surface is three. And that is where triangle becomes the very basic geometrical structure or geometrical figure where we can create a closed surface by taking the minimum number of straight lines. So for example, if you take two straight lines, you can never create a closed surface. The minimum number of sides or minimum number of straight lines that are needed to create a closed surface is three, and that is where we are starting our discussion about geometrical structures with the very basic one, that is triangles for grade 9 mathematics students. Okay, so let us, before we go into and understand the properties and the theorems, let us pause for some time and understand some of the basic notations. Okay, so first and foremost thing, obviously a triangle has three angles, right? And obviously it has got three sides. What else? These three points these three points okay, which are actually limiting a triangle, are called vertex. So this is a vertex, this is a vertex, and this is a vertex. And how do we denote them? So we may use any letter of your English alphabet. So say I'll say this is A, this is B, this is C. Again, it's not mandated that you would name it as ABC. You may name it A, B, C, whatever, or may even name it as PQR, XYZ, whatever you prefer, you may name it accordingly. Okay. So in this ABC triangle, there are three vertex also. So the three vertices are A, B, and C. So I repeat, vertex are nothing but the limiting points of a triangle, right? Because obviously we know when we say three straight lines, we have used, it can actually be, your straight lines like this, right? We may produce it on the both sides. So if you see these vertex A, B, and C, they are actually limiting or they are defining the boundary of this geometrical figure, and they are called vertices, vertex A, B, and C. Now, there are also three sides in the triangle. So the next notation is about sides, and the way we denote sides is we denote them by both the vertex that are forming that side. So the three sides in the triangle are AB, and notice we put AB bar, BC bar, and CA bar. Okay. Now, if a student doesn't want to write it AB, he or she wants to write it as BA bar. This is absolutely right. Okay. So it's not mandated that you should always go in an alphabetical order. You just need to indicate both the vertex. Okay. That is it. And obviously your AB bar is absolutely same as BA bar. So there is no difference, and you may choose to write it as per your own convenience. But notice when we are talking about a side, this bar symbol is ideal and you should be putting it. Now, in your books and in many places, you would have also seen that they do not use this bar. And let us understand what is the difference between putting the bar and not putting the bar. So when we put a bar on it, this means we are talking about side AB. But if we are not putting the bar, if it is just AB, this means the measurement or the length of this. So whatever is the length, suppose it is L units. Okay. So AB means measurement or length of AB is called AB. So a small, notation difference, but yes, it makes a difference when you are trying to, read and write mathematics in the right way. Okay, AB bar indicates the AB side, but only AB without the bar indicates the length or the measurement of AB. Okay, now let us go to one more notation. So we are done with vertex. We are done with sides. Now let us slowly move our discussion towards angles. Okay. So I'm erasing it because we need more real estate. Okay. So now let us write down the three angles that we have in this triangle. Okay. So what are the angles? There are two ways of denoting the angles. One, you may just indicate angle A, angle B, and angle C. So just choose the vertex and use this symbol, and that is how we denote angles A, B, and C. But I personally prefer, rather than this, to use the second approach, that is, to denote angle A, let us write angle BAC, okay, so that the vertex stays in the middle and the other two, surround it. Okay, so angle BAC, and the benefit is when we say angle A, it could be this interior angle, it could be the exterior angle. So that is why, to remove that confusion, I always prefer writing this bigger one, angle BAC. Okay, and similarly angle B could be written as ABC, and angle C could be written as BCA or ACB. Again, just like we studied for sides, here also you may also write angle BAC is absolutely same as angle CAB. But remember, if you change the vertex, angle BAC may not be equal to angle CBA, because when you are writing CBA, you are intending this angle, this second one, where vertex is B. Okay, so that's why this notation is important. Okay, so if you have understood about these notations, let us move a step further. Let us move a step further and see how do we denote our triangles. Very simple notation to denote a triangle. That is, we write ABC triangle. Okay, ABC triangle. And in case if it's a right angle triangle, we denote ABC like this. Okay, so only for right angle triangles we may denote like this, and for any other triangle we can write ABC triangle. Even for a right angle triangle, if you use this notation, that is absolutely right, it's not wrong. But for right angle triangles specially, you may use this notation. Okay, so this is about the basic notations of triangles vertices, sides, angles. Now, now let us see one more small and interesting thing is whenever we say angle A, what is the opposite side of angle A? If you notice in the triangle ABC, if I just drop vertex A, the other two vertex opposite side of angle A would always be BC bar. Similarly, opposite side of angle B would always be AC bar. So leave this vertex, write other two vertex, give a bar sign. So that is how it would always be. Angle C, the opposite side of angle C would always be AB bar. Now, one more small notation. When we want to indicate the measurement of an angle, ideally we should say, or ideally we should denote it as measurement of angle B, or we may say measurement of angle ABC. Many a times in books they don't use measurement of, that's fine, because this is also acceptable that angle B is also read as your measurement of angle B. However, in case of your straight lines, they use this notation. AB bar indicates that straight line, but only AB indicates length of the straight line denoted by your AB side. Okay, but for angles, you may use both this notation and this notation. So with this, we are done with all the notations that I wanted to walk you through related to triangles. Now, let us go and understand and rather recap some of the basic properties which we know, and probably I would add just one or two more properties to it. Okay, so we are just getting into the properties. So before this it was just a basic introduction. So now, before we get into properties of triangles, let us just pause for a minute and let us notice this thing, right? How do we normally form a triangle? So say, can I say that, let me create an angle, say angle A. Okay, I don't know other two vertex, so I have not yet named them. Okay, now this is how we normally create an angle, right? That when two arrays are co-initial, they form an angle at the co-initial point, and this angle is suppose something or theta. Okay. now now suppose on these two arrays, okay, I would imagine that, say, let this point be B, let this point be C. Okay, so I have fixed a length of AB, I have fixed a length of BC. Now when I am limiting the angle, see what is the geometrical figure we are getting? Triangle. So every triangle is nothing but an angle limited on its opposite side. If you look from this side, angle B, this is how angle B is created. When angle B is limited at points A and C, it becomes the same triangle. Similarly, when angle C is limited on both the sides by point A and B, it becomes this ABC triangle. So I repeat, you may note it down also. Every triangle, every triangle is nothing but nothing but an angle which is limited on its opposite side. Okay, and that is the reason I'm telling you this theory, because obviously you will not get this theory directly written in any book. But the reason why we should know this is the next line. You should understand that, always remember, students, whenever we are discussing about any particular triangle, now suppose I'm going with triangle ABC. Okay, in any triangle, note it down that there is a there is a strong correlation between any angle and its opposite side. Any angle and its opposite side, its opposite side in a triangle. Okay, so whenever we are discussing about any particular triangle, remember students, there will always be a strong correlation between the angle and the opposite side. What does that mean? Let us try to understand. Okay, so in this figure I had drawn angle A. Okay, now let me not change the length of AB and AC, and let me increase angle, this angle from this much to this much. Okay, so suppose I would draw, I have not changed the length of it. If I draw a similar length, okay, suppose this is your C prime, and I have increased the angle from theta to, suppose now the bigger angle is alpha. Now, if when I have increased the angle, are you able to recognize that your length of BC prime is greater than BC? Okay, so always remember students that there is always a correlation between angle and its opposite side. Okay, so that is why whenever you talk about any one particular triangle, let us just draw a couple of triangles on the board and try to see it more clearly. Okay, say let us draw this as a triangle. Okay, or let me rather draw it little like this. Okay, so in this triangle, if I'm saying A, B, C, so if you see visually, it looks like A is the largest angle. And if you see this, what is the side opposite to A? That is BC. So if you see, if angle A is largest, which means angle A is greater than B and C. Now we don't know the relationship between B and C, but say if angle A is greater than both of them, the opposite side of A, that is BC, will also be greater than the side that is opposite to B, that is nothing but AC, and side that is opposite to C, that is nothing but AB. So suppose this angle is largest, and say if B is second largest and C is the smallest, then if you would notice that if your angle A is greater than angle B, greater than angle C, then what is the opposite side of A? It is BC, would be greater than opposite side of B, that is nothing but AC, would be greater than opposite side of C, that is nothing but AB. Okay, so that's why remember in a triangle there is a strong correlation between angles and their opposite sides. The angle that is the largest, side opposite to that would be largest. Angle that is smallest, side opposite to that would be smallest. Okay, that is why you would have also seen. Now let us try to compare few other type of triangles that we already know. Okay, say let us talk about a right angle triangle. In a right angle triangle, we know that the highest angle is this 90-degree, and that is why which one is the largest side? This one, the hypotenuse. So that is why remember students that is why in a right angle triangle, hypotenuse is always the largest side of a right angle triangle, because there's a strong correlation between any angle to the opposite side in a triangle. That is one of the fundamental reasons why in a right angle triangle, hypotenuse is always the largest side. Okay, similarly, if we talk about your isosceles triangles, Okay, so say when we know that to this side, then what is the angle opposite to this side? That is this. And what is the angle opposite to this side? That is this. So remember, students, if two sides are equal, then in an isosceles triangle, angles opposite to them are equal. Okay, so we know that just because these are isosceles triangles, I cannot say that this angle and this angle would be equal, because if this side is equal to this side, then angles opposite to those sides have to be same. It cannot be haphazardly any two sides of a triangle. Okay, similarly in an equilateral triangle, what happens in an equilateral triangle? In an equilateral triangle, as all three sides are equal to each other, that is why all three angles are also equal to each other, and they are 60-degree each, right? So these are some of the basic properties of triangles, which would be very much useful when we solve some of the geometrical problems